Hello, this is Mrs. Ringrose, and I just wanted to go over this answer key with you since we might not have had a lot of time to work together when we reviewed in class. This is your homework, and if any of these questions you just want to skip through, then feel free to do so. So the first one, or the first set of problems, is just asking you to use the Pythagorean Theorem. So we don't know anything about the angles yet, so we don't want to have to use 30, 60, 90 or 45, 45, 90 special rules. So it's just straight up Pythagorean Theorem. So number one would be 12 squared plus x squared equals 20 squared. And you do all the famous work to solve for x, which would be 144 plus x squared equals 400. X squared equals 256, and then I square root both, and x equals 16. Don't forget that x is a leg and not the hypotenuse on this one. The hypotenuse is 20 because it's across from the right angle. Next one, you're going to set up x in the hypotenuse location. So it's going to be 9 squared plus 13 squared equals x squared. And your answer is 250 equals x squared. So when I take the square root of 250, I notice it's not a whole number, and they want our answers to be in simplest radical form. So you're going to want to divide 250 into factors, one of which being a perfect square. This one's not too hard. It's 25 times 10. So I can take the square root of 25 and get 5, and 10 remains under the radical. So that's actually your answer. Number 3, x is going to be set up in the leg. You end up with x squared plus 15 squared equals 21 squared. And when you do all that magical solving, you get x squared equals 216. Which is actually a perfect cube, and I happen to know it because Mrs. Ringrose memorized a lot of perfect cube numbers. But if you don't know and you run through the list, you would find that 36 is the biggest perfect square number that divides evenly into 216. So now I get 36 times 6. So x equals, because I can take 36 out of the radical, I get 6 radical 6. Right, 4, 5, and 6, your job is to apply the Pythagorean Theorem converse. If c squared is larger than the sum of the square of the legs, it's obtuse. If their sides are equal, it's a right triangle. And if c squared is less, then it's acute. So number 4, when you square everything, it looks like 5 squared plus 15 squared equals question mark parenthesis 5 radical 10 squared. So I would recommend you put it in the calculator just like that. What happens is the square goes on both of them. So it's 25 because 5 squared is 25, and radical 10 squared is just 10. So this side is 25 plus 225, which is, they're both equal. So this one's a right triangle. Right, when you use the Pythagorean Theorem converse and both sides are equal, it's a right triangle. Number 5, I just, again, plug them in the calculator. 4.3 squared plus 6.7 squared gave me 63.38. And then I'm trying to compare that to 8.2 squared, which was 67.24, I think. Yep, or 74, no, 24. So which side looks bigger? Clearly the c squared side is bigger. So, and the c side is bigger, it's obtuse. And then finally, number 6. 5 squared plus 7 squared. How does that compare to 8 squared? So I end up getting that 74 is bigger than 64, which makes this acute. So when the sum side is bigger, then it's acute. right, 7 through 9 are where we use our proportions for similar right triangles. And I gotta tell you, I actually had a hard time with number 8 myself. But hopefully, if you can do any of these, you can do number 7. Number 7 is the one I tried to impress upon you the most. When you have the two breakaway pieces of the hypotenuse, which is the short leg and the long leg of the two triangles in there, x ends up being the geometric mean. And all you need to know about geometric mean is that it goes cross-side of each other, so they end up getting multiplied. So then I put 20 in one spot and 5 in another spot, and then I cross-multiply to solve. So x squared equals 100, and then I take the square root of both, and I get x equals 10. All right, this one, there's probably another way to do it that might be easier, but when I investigated this, I realized that on this triangle, I have a long leg and a hypotenuse, but on the other triangle, I just have legs. No, I'm sorry. On the other triangle, I have a short leg and a hypotenuse. So you can't mix up, and then on the big triangle, I have only legs. So I can't mix up short legs and big legs. So what I did was I used the Pythagorean Theorem, and I found that the big hypotenuse was 26. You could also actually end up using a Pythagorean triple. It's a 5, 12, 13 triangle. Yay for Pythagorean triples. So then the way I set it up was I said that, how did I set this up? Okay, so I said hypotenuse over short leg equals hypotenuse over short leg. And that was my proportion that made the most sense to me after I looked at this for a while. And you cross multiply and you get 26x equals 240. And I divide both sides by 26. And I get x equals 9.2. Alright, so I hope that made sense to you. Because again, I had to put a lot of thought into that one. Sometimes you just have to use Pythagorean Theorem first. But again, there might be an easier way to do that. Number 9. Again, I recognized the relationships and discovered that I needed to add these together and get 15 because I need that long hypotenuse. And then the ratio I set up was long leg over hypotenuse of the big triangle, and then long leg over hypotenuse of the medium triangle. And then I have x squared equals 180. And so I got x equals 13.4. So, we're making some good progress here. Again, if you have any questions, you can send me an email or a remind message, and I'll try to answer them as best as possible. All right, 10 through 12, definitely something that you should know because you need this in real life all the time. JK, but it's good to know. So this one, number 10, is going to be a 30, 60, 90 triangle, which means I'm going to use the ratio that the side across from a 30-degree angle is x, the side across from the 60-degree angle is x radical 3, and then the hypotenuse is 2x. So if my short leg there is 4, that means x equals 4 radical 3, and y is going to equal 8, because I just have to times 4 by 2. Number 11, 45, 45, 90 triangle. So that means x is going to be 24, because it's an isosceles triangle. And then the hypotenuse is whatever the leg is times radical 2. Okay. Number 12 is a little bit more work. So I know that this is equal to 2x, because x is my side across from the 30-degree angle. So I'm going to just set this equal to 2x and see if I can't solve this easily. Divide by 2, and x equals 3.5 radical 3. Or you can leave it 7 over 2 radical 3. Okay. Then, what I need to do to find y is y is going to be whatever my x is times radical 3. Right? So and you don't want to leave it with two radicals. Both those numbers are under the radicals, so that means I can multiply both those numbers together. So your final answer is y equals 3.5 radical 6. I don't have any perfect square factors under that, because the only factors of 6 are 3 and 2. So I can leave my answer like that. All right. Going on 10 minutes. I get a 15-minute limit. I hope you're just skipping around and trying to find, the parts that you need help on. All right, so 13, you're trying to solve the right triangle. When you're solving right triangles, you want to find all the unknown angles and sides using any method you want. I believe I used Pythagorean Theorem to find the hypotenuse, and I rounded it to the nearest tenth, which came out to 12.1, I think. Yep, 12.1. All right, then I have options to find the angles. Because I had to round the hypotenuse, I didn't want to use cosine or sine. So I said that the tangent of C is equal to opposite over adjacent. And then I did the inverse of tangent to find the measure of angle C. And when I plug that into the calculator, I got 65.6. Okay, again, we're rounding to the nearest tenth. And then what I could do is, if you want, you can do an inverse tangent of 5 over 11 to find A, or you can just subtract 65.6 from 90, and I got the measure of angle A equals 24.4. Away. Number 14, same exact setup. You are given two sides, and you need to find the last side. I used Pythagorean Theorem, and I found out that this was 7.8. You could use trigonometry if you wanted to, but I thought that was the better way to go. Then what I did was, I don't know why I used tangent again. I should have used cosine, or sine. But I did the tangent. It's not good to use a rounded answer, but what are you going to do? I said that the tangent of D is equal to 7.8 over 5.4. And then the inverse of 7.8 over 5.4 gave me 55.3 degrees. So that means D is 55.3 degrees. And then I can subtract that from 90 to get the measure of angle F, which was 34.7 degrees, I think. All right, number 15, you do not have two sides, so you must use trigonometry. You're given the measure of angle J, so you want to make sure that if you use a trig function, you use one that uses adjacent, because you're given 14. So you can go ahead and do tangent, or you can do cosine. I did tangent of 53.2 would give me opposite over adjacent. And then, so in the calculator, I literally just did 14 times tangent 53.2, and that gave me, rounded to the nearest tenth, 18.7. And then I don't have any more work on my paper, so I'm assuming I used Pythagorean Theorem and found that was that. And then you can subtract 53.2 from 90 and get the other angle, which I didn't do on the paper, but you can handle that. All right, so unfortunately, I have seconds left. Man, I talk a lot. Number 16 is not a trigonometry question. Number 16 is similar right triangles. So this is the one where we did this, and she's got that cardboard square, so we know it's a right angle. And she's 6 feet tall, so that means this is 6. And she's 15 feet away, and you're looking for the total height. So you can set up a proportion where 15 is the geometric mean, and don't forget when you find h, then you add it back to 16. Okay, and then number 17 is definitely a trig question, which I know you guys can handle. Good luck on the test.